Hi, I'm Rob. Welcome to Math Antics. We've already learned a little about how exponents and roots are used in arithmetic, and now it's time to learn the basics of how they're used in algebra. As you know, one of the main differences between arithmetic and algebra is that algebra involves unknown values and variables. In arithmetic, you might have the exponent 4 squared, but in algebra, you're more likely to see the exponent x squared. And when it comes to roots, instead of seeing the square root of 16, you might see the square root of x. Of course, one of the main goals in algebra is to figure out what those unknown values are. And we're going to learn a bit about how to do that in a minute. But first, we're going to learn something about exponents by looking at an important pattern in algebra. It's the pattern formed by the expression x to the nth power, where n is any integer. In this expression, x could be any number, but n can only be an integer. And to keep things simple in this video, we're only going to consider non-negative integers. That is, we'll limit n to be this set of numbers, 0, 1, 2, 3, and so on. If n is 0, then we have x to the 0th power. If n is 1, then we have x to the first power. If n is 2, then we have x to the second power, or x squared. If n is 3, then we have x to the third power, or x cubed. And we could keep on going with this pattern, x to the fourth, x to the fifth, to infinity. Okay, but what do these exponents mean? Well, x squared is pretty easy to understand. We know from our definition of exponents that x squared would be the same as x times x. We also know that x cubed would be x times x times x. And going up to higher values of n would just mean multiplying more x's together. But what about x to the first power? Well, if x to the second power means multiplying two x's together, then x to the first power should mean multiplying one x together, which sounds kind of funny when we say it like that. But as you can see, that pattern makes sense. X to the first power would just be x. And that helps us see an important rule about exponents. Any number raised to the first power is just itself. This rule, or property, is similar to the identity property of multiplication that says any number multiplied by 1 is just itself. Okay, so x to the first power makes sense, but what about x to the 0th power? Does that mean no x's multiplied together? That seems even stranger, and the rule about the 0th power may surprise you. It seems like x to the 0th power should be 0, but it's actually 1, which will make a lot more sense if we modify our pattern a little. Do you remember that because of the identity property of multiplication, there's always a factor of 1 in any multiplication problem? 4 is the same as 1 times 4. 5 is the same as 1 times 5, and so on. Well, that means we can also include a factor of 1 in our pattern of exponents. X to the first is 1 times x. X to the second is 1 times x times x. X to the third is 1 times x times x times x, and so on. And if we continue that pattern the other direction, you'll see that there will be a 1 left there even when all the x's are gone. So now you know another important rule about exponents. Any number raised to the 0th power is just 1. Knowing these rules about exponents is important in algebra and will help us when we talk about polynomials in the next video. But for the rest of this video, we're going to learn how to solve some really basic algebraic equations that involve exponents and roots. Let's start off with this equation. The square root of x equals 3. How do we solve for x in this equation? In other words, how do we figure out the value of x without just guessing the answer? Well, we know that the key to solving an algebraic equation is to get the unknown value all by itself on one side of the equal sign. And you might be thinking that in this equation, the x looks like it's already by itself. After all, there's no other numbers with it. But getting an unknown by itself means we need to isolate it from any other numbers and operators so that it's completely by itself. In this equation, that means we need to somehow get rid of the square root sign that the x is under. Aha! Need to get rid of that pesky square root sign, do you? Let's see, I'll just use my magic wand and... that usually works. Ah, I know. This is gonna be harder than I thought. 1, 2, whoa, hold on now. That seems a bit extreme, and it won't even help. I mean, this is a math operation, And to get rid of a math operation, you need to use its inverse operation. Well, I was gonna try that next. In the video called Exponents and Square Roots, we learned that exponents and roots are inverse operations. If we want to undo an exponent, we need to use a root. And if we want to undo a root, we need to use an exponent. So in this equation, to undo the second root or square root of x, we're going to need to raise it to the second power or square it. If we square the square root of x, those operations will cancel out and we'll be left with just x. But why does that work? Well, you can see why it works if you remember what the square root of x really means. The square root of x is a number that we can multiply together twice to get x. For example, the square root of 4 is 2 because if you multiply 2 times 2, you get 4. So since the square root of 4 is the same as 2, we could also just say that the square root of 4 times the square root of 4 is 4. And do you see how the square root of 4 times the square root of 4 is the same as the square root of 4 squared? And this is true for any number, which is why squaring the square root of x just leaves us with x. The exponent and the root operations cancel each other out. Okay, so we can undo the square root by squaring that side of the equation. But remember, to keep our equation in balance, we need to do the same thing to both sides. So we need to square the 3 also. 3 squared is 3 times 3, which is 9. There. By squaring both sides of the equation, we changed it into x equals 9. We solve for x. That was pretty easy. Let's try solving another simple problem with a root. This one is the cube root of x equals 5. Just like before, we need to get x all by itself by undoing the root. But since it's a cube root this time, we can't undo that by squaring both sides. Instead, we need to cube both sides. You always need to undo a root with the corresponding exponent. Third root, third power. Fourth root, fourth power, and so on. So to solve this equation, we need to raise each side of the equation to the third power. On the first side, the operations cancel, leaving x all by itself. And on the other side, we have 5 to the third power, which is 5 times 5 times 5, or 125. So, x equals 125. All right, so that's how you solve very simple one-step equations with roots. What about simple equations that have exponents instead of roots? Like this one, x squared equals 36. Again, we need to get the x all by itself, which means we need to deal with the exponent on this side of the equation. How do we undo an exponent? Yep, we use a root. Since the x is being squared, if we take the square root of x squared, the operations will cancel out, leaving x all by itself. But why does that work? Well, think for a minute about what the square root of x squared would mean. It means that you need to figure out what number you can multiply together twice in order to get x squared. But that's easy. X times x is x squared, so that means that the square root of x squared is just x. So to solve this equation, we take the square root of both sides of the equation to keep things in balance. On the first side, the operations cancel out, leaving x all by itself. And on the other side, we have the square root of 36, which is 6. So the answer to this problem is x equals 6. Well, that's half of the answer anyway. This problem's actually a little more complicated than it looks at first, thanks to negative numbers. Do you remember in our video about multiplying and dividing integers? We learned that if you multiply two negative numbers together, the answer is actually positive. That turns out to be really important when it comes to roots, because it means that there's often more than one answer. For example, we know that the square root of 36 is 6 because multiplying 6 times 6 gives us 36. But because of that rule about negative numbers, negative 6 times negative 6 is also 36. So it would be just as correct to say that the square root of 36 is negative 6. So which is it? Is the square root of 36 6 or negative 6? The answer is both. This is an example of a simple algebraic equation that has two solutions. X could be 6 or x could be negative 6. X can't be both 6 and negative 6 at the same time. but you could substitute either value into the equation and it would make the equation true. So in algebra, when we have a situation like this, where the answer could be positive or negative, we use a special plus or minus sign that looks like this. X equals plus or minus 6. And we use it when we're finding even roots of a number, since we know that the answer could be positive or negative. But what about odd roots, like the cube root of a number? Like, what if we have to solve the equation x cubed equals 27? To solve this equation for x, we need to take the cube root of both sides. On the first side of the equation, the cube root will cancel out the cube operation that's being done to x, leaving x all by itself. And on the other side, we need to figure out the cube root of 27. Using a calculator, or just by knowing about the factors of 27, we see that the cube root of 27 is 3, because 3 times 3 times 3 is 27. So in this equation, we know that x equals 3. But what about negative numbers? Is x equals negative 3 also a valid solution to this equation? Nope, and here's why. If you multiply negative 3 times negative 3 times negative 3, the answer would be negative 27, not 27. So the cube root of 27 is 3, but not negative 3. In this case, there's only one solution. All right, in this video, we learned two important rules about exponents. We learned that any number raised to the 0th power equals 1, and that any number raised to the first power is just itself. We also learned how to solve very simple one-step equations involving exponents and roots. Since they're inverse operations, to undo a root, you use its corresponding exponent, and to undo an exponent, you use its corresponding root. Of course, there's a lot more to learn about exponents in algebra, but those are the basics. And to make sure you really understand them, it's important to practice by doing some exercise problems. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.